Okay, function catalogs. We're going to be doing function catalogs the entire school year. So you just get used to them. Sometimes we'll do them a couple a week. Sometimes we'll do two one week, we'll skip a week, and then we'll do one another week. So they just kind of are, they show up at random times. Now, here's what I need you to know about this particular problem. Whenever you see an equation as simple as x equals 3, x equals 3 is what we're gonna call a vertical line. It's going to be a line when we go to graph it, it's just going to be straight up and straight down. So, x equals 3. Let's write some information about this. Its name is called a vertical line. And the pre-work, what do we know about vertical lines, or what do we know about an equation that looks like this? X can only be 3 no matter what. X cannot be any other number. If it was x equals 5, then x could only be 5 for that problem. So what that's going to tell us when we go down here to our table, we're going to make a little XY table. Since our pre-work says x can only be 3, that means our table is going to have a bunch of 3s in it. Typically in pre-algebra and algebra 1, when we're making tables, we always plug something in and do a calculation to get a y answer, correct? But for a vertical line, there's really nothing we can do in this regard. And so what I kind of want you to think about, you don't have to remember this until next time, is what we're going to do is we're going to create our own y's. Since x is always 3, y could be anything it wants. And this table is going to give us our coordinates on where we're going to put our dots to plot. And if you notice, as we get these dots to plot, they are going to create a perfect vertical line. Now get your ID card. You're going to use your ID card a lot. Whenever we do a function catalog, we're going to draw a picture, and I want that picture to be as straight as possible. So if you have a ruler, great, but most of us have an ID card. So get your ID card out. And what we're going to do is we're going to draw the line through these dots. Now, I have a couple of rules about this. Don't give me one of these like little silly lines that just goes through the dots and stops. When we're drawing pictures for function catalogs, let's make sure our picture stretches across the entire space. So far so good, pretty easy. You don't have to study this or memorize this weekend, unless you really want to. I'm not going to force you or require that. We're just filling it out and moving on with our lives. Now, what is the parent function for this particular problem? You don't know this yet. You won't know this for about a month and a half, but we're going to write it down anyways. The parent function for x equals 3 is x equals 0. Don't worry about memorizing that right now. That more information to come about that. If x equals 3 is a vertical line through over here, look how it's x equals 3. Where would x equals 0 most likely be? it's going to be a vertical line through 0. Zoom in there for you so you can see that. If x equals 3 is a vertical line through that 3 number, then x equals 0 is going to be a vertical line through the 0 number. What's the transformation equation for this x equals 3 vertical line? Again, don't worry about y yet. We're just copying this down and moving on. The transformation equation is x equals 3. We won't really know why that's the transformation equation until about a month or two from now. So don't worry about it. Just write it down and move on. Did we draw a function? Does everybody remember from like pre-algebra and algebra 1 in middle school, those silly things called the vertical line test or the pencil test? Maybe, maybe not. We'll blame Summer Rust. It's been a while since you've done it. Did we draw a function here? No, we did not, because if we did a vertical line or a pencil test, notice how when the pencil goes over here, I hit more than one dot. I actually hit 4 dots at the same time, right? When you hit 2 dots, 3 dots, 4 dots, 5 dots at the same time, that's a problem. So the answer is this is not a function because we don't hit 1 dot every time. We hit 4 dots at one time, so that's not good. Again, just write that down. We're going to spend more time on that later. Skip the verbal description for right now, and let's go to this lower part. Let's start answering some of these questions. Again, most of these is more for later. We're just writing it down. What is the domain? The domain is X-only information. Well, for this problem, what is the only X being used? X equals 3. For the range, that is Y-only information. When we were making our table, did we have to use 1, 2, 3, and 4? No. Could we have used other numbers? 5, 6, 7, 8, 0, -1, -2? Sure. I could have used anything I want. So for the range, we're going to put something called all real numbers. Now, some of you are lazy. I'm lazy. I'm going to use a symbol that stands for all real numbers. It's a capital R. Notice how this capital R has this extra little like backwards flare going on. Then from that, I'll draw another marking downward. That symbol right there stands for all real numbers. Again, don't worry about studying this over the weekend. We're going to review this until over the next few weeks. Do you remember from pre-algebra and algebra 1 that a vertical line has a slope that's undefined? If you don't, no big deal. In a couple of weeks, you'll have to remember that. Does a vertical line have a vertex? No. Axis of symmetry? No. Is it increasing or decreasing? I don't know. It's increasing and decreasing at the same time. So I don't know which one it's doing. It's kind of a weird thing to say. Does it have an x-intercept? All right, so these guys right here, x-intercept, y-intercept, we have to do a little bit of work. Now, here's what you need to know about these guys. For the y-intercept, x always equals 0, and for the y-intercept, y always equals 0. That's just a math rule. Again, don't memorize that now. In about a month, you'll have it memorized. So this wants the x-intercept for first. For the x-intercept, y equals 0. So we're going to go ahead and put a 0 in the y location. Now, for this particular problem, x is always what number? X is always 3. No matter what, no matter where, the x position is always 3. We kind of just mentioned that in our pre-work. So our x-intercept answer is 3, 0. Which actually kind of makes sense, because if you go look at your picture, that appears to be where it's hitting. Now our y-intercept. X equals 0. Can x be 0 for this problem? No. There's a conflict because x can only be 3. And so what we're going to say is, when there's a conflict, it does not touch. And if you look at it, go up and look at your picture. Does it touch the y-axis? No, it does not. So that's going to be that answer. Some of you are like deer in headlights, like your eyes are like, what is he talking about? What is this? I'm already lost. Don't worry about it. We're just writing all this down. I'm telling you a bunch of stuff that you're going to forget in 10 minutes. It's fine. We're going to do this every few days for the next month, and a month from now it'll all be fine. Okay, so just don't stress. Is there a horizontal asymptote? No. Is there a vertical asymptote? No. Is there a max or a min value? What does this mean? Does our picture go up and stop? Does it ever get to a high location? No, it keeps going and keeps going and keeps going. It never has a max. It never has a ceiling. In the same regard, does it ever stop going down? No. Does it have a low point? No, it does not. So max value is, does it have a high point? And min value is, does it have a low point? And the answer is no, because of the arrow for both of them. It never has a high point or a low point because the arrow keeps forcing the picture to go up and up or down and down. Now let's go to our verbal description. It's like the last thing you do. Here's what you write. You don't know what you're going to write, but here's what you write. Always write the following. Start every verbal description with the, and then use its name. The vertical line, moved, the parent function, well, look at your two pictures. The parent function was at 0. The regular picture was at 3. How did the top right picture get moved? It looks like it got moved 3 spaces to the right, kind of, sort of. So that's we're going to go ahead and say that. The vertical line moved the parent function 3 spaces to the right. Period. It has a domain of x equals 3, a range of, now I'm going to use the symbol because I'm lazy and I like to do shortcuts. All real numbers. A range of all real numbers, and, comma, and an x-intercept at, and then we'll write that down, 3, 0. There is no y-intercept. I'm going to highlight generally what should be in every function catalog. And then you just sort of fill in the blanks depending on what problem we're dealing with. So we'll come back and talk more about that later. All right, if you copied exactly what I did, you'll get full credit when you turn in FC number 1.